All right, and we are recording, man. Hey, what's up? And welcome to yet another part of the show. Always just very fascinated to jump in and do this. So I'm excited. First of all, I always have Microsoft Bing's daily wallpapers. I think this is the best. I think, in my opinion, wallpaper apps out there because it just feed me things that I really marvel. I love this kind of thing a lot. I wonder what this is. This looks like an ocean and a creek at the same time. It's really creepy. What is this? Maybe an underground creek, an aerial shot. Really cool. But that's not the point. We're gonna we're gonna do read along today. Uh, the Secret Life of Objects. I had started this read along at the shop, and man, it was so tough to go through this one. So my hope is that for the next few minutes I'll be able to go through this one, and we're just going to enjoy learning about this. So let's go. Secret Life of Objects. Um, an abstract data type is realized by writing a special kind of program which defines the type in terms of the operation which can be performed on it. All right. This is Barbara Liskov from the book Programming with Abstract Data Types. Okay. So here we have an image of a bunny, and then I think this is like an abstract type, a geometrical abstract type of the same bunny. Interesting, like a reflection, like a mirror. Hmm. Maybe this will be something to teach us more about objects. So chapter 4 introduced JavaScript objects. In programming culture, we have a thing called object-oriented programming, a set of techniques that use objects and related concepts as the central principle of program organization. Though no one really agrees on its precise definition, object oriented programming has shaped the design of many programming languages, including JavaScript. This chapter will describe the way these ideas can be applied in JavaScript. Encapsulation. So, the core idea in object oriented programming is to divide programs into smaller pieces and make each piece responsible for managing its own state. Okay? This way, some knowledge about the way a piece of the program works can be kept local to that piece. Someone working the rest of the program does not have to remember or even be aware of that knowledge. Whenever these local details change, only the code directly around it needs to be updated. Different pieces of such a program interact with each other through interfaces, limited sets of functions, or bindings that provide useful functionality at a more abstract level, hiding their precise implementation. Such program pieces are modeled using objects. The interface consists of a specific set of methods and properties. Properties that are part of the interface are called public. The others, which outside code should not be touching, are called private. Many languages provide a way to distinguish public and private properties and prevent outside code from accessing the private ones altogether. JavaScript, once again, taking the minimalist approach, does not yet at least. There is a work underway to add this to the language. So, even though the language doesn't have this distinction built in, JavaScript programmers are successfully using this idea. Typically, the available interface is described in documentation or comments. It is also common to put an underscore character at the start of the property names to indicate that those properties are private. Separating interface from implementation is a great idea, and it's usually called encapsulation. So here we've just learned about this idea in programming called encapsulation. Now we talk about methods. Methods are nothing more than properties that hold function value. This is a simple method. Let rabbit, this is an object literal, close it. Rabbit.speak equals function, and then that function should say line, should call line, and in the argument want to call the console log. The rabbit says template literal line. Okay, and we close it. Rabbit.speak I'm alive. It will call the rabbit says I'm alive. Okay, this is rabbit.speak, and this function has been wrapped inside this method. So usually methods need to do something with the object it was called on. When a function is called as a method, looked up as a property and immediately called, an object.method, as in object.method call, the binding called this in its body automatically points at the object that it was called upon. So let's copy this. In fact, let's copy until here, and then we're going to copy this on our console. I wish I could clear. How can I clear? Clear console. Okay. Control V. Let's run that. The rabbit says I'm alive. Okay. So undefined. Okay. Usually, okay. So here a method needs to do something with object was called on. When a function is called as a method, looked up as a property and immediately called as an object.method call, the binding called this in its body automatically points at the object it was called upon. So there's a binding called this, I think, that exists inside this object rabbit. Okay. Function speak line. So and then now with a new function called speak console.log the this.type rabbit says line. Let white rabbit is another object be type white speak. Let hungry rabbit be object type hungry speak. White rabbit speak. It will say, oh, my ears and whiskers, plus, so this we're concatenating this string, plus, oh, how late it's getting. Then when you run it, the white rabbit says, oh, my ears and whiskers, how late I'm getting. Rabbit.speak, it will pull here this, which is the white rabbit, says it will pull this line. Alright. The hungry rabbit would speak. I could use a carrot right now. It will say, the hungry rabbit says, I could use a carrot right now. Alright. So let's look at this again. Let's copy this. Let's clear our console. Let's run this. The white rabbit says, oh, my ears and whiskers. Okay, so now, how can I make this bigger? Control plus, control plus, control plus, control plus. Okay, so let's look at our console. So function speak line console.log the template literal this.type rabbit says template literal line. Oh, remember this template literal can be used as a placeholder for so yeah Alright, so a template literal is you can have a sentence that uses this thing over here. What do you call this type of apostrophe? The one that is on top of tab. And then this will be the template literal, but this is like a placeholder for the template literal. Okay, so this dot type, so this dot type is a method. Rabbit says line, so let white rabbit be, and we're going into white rabbit and we're getting type from this property, white speak. And then hungry rabbit, we're getting type from this property, speak. And when we say white rabbit dot speak, or my ears and whiskers plus how late it's getting, it will give you on the console. The white rabbit says, oh, my ears and whiskers, how late it's getting. So let's try and copy the next code. Control C, let me bring this here. Control V, enter. The hungry rabbit says I could use a carrot right now. So this code works. This code works. We shall break it down in the next, but this now we're just reading alone. So you can think of this as an extra parameter that is passed in a different way. If you want to pass it explicitly, you can use a function's call method, which is the brackets, which takes this value as the first argument and treats further arguments as normal parameters. So speak.call hungry rabbit burp. It will call the speak and this call. The hungry rabbit says burp. Since each function has its own this binding, whose value depends on the way it is called, you cannot refer this to the this. You cannot refer to the this of the wrapping scope in a regular function defined with the function keyword. Okay? Arrow functions are different. They do not bind their own this, but can see the this binding of the scope around them. Thus, you can do something like the following code, which references the this from inside a local function. So function normalize. So the function is normalize, and then we're going to pass in the arguments console.log this chords.map, and then arrow function n this dot length. Okay, and so what then happens is that when you normalize dot call and you pass this argument, it will give you this array 0, 0.4, 0.6. Okay, so if I had written the argument using map to map using the function keyword, the code wouldn't work. Prototypes. So now we have learned about methods and that methods exist in code. So now let's look at prototype. Watch closely. Let empty be this object, console.log empty.toString. Let's try this. Control C. Alright, so let's clear our console. Control V. So let empty be an empty object, and then console.log empty, which is this variable, dot to string. This is new. Okay, what will we get? We'll get function to string. This is native code to string. What is that? This is what we've gotten. Console.log empty.toString. So let's call this one now. So it's empty.toString call. Let's run this one. And you've gotten object. We get this array object, object. So I pulled a property out of an empty object. What? Magic! Okay, well, not really. I have simply been withholding the information about the way JavaScript objects work. Okay? In addition to their set of properties, most objects also have a prototype. A prototype is another object that is used as a fallback source of properties. When an object gets a request for a property that it does not have, its prototype will be searched for the property, then the prototype's prototype, and so on. So, who is the property of that empty object? It is the great ancestral prototype, the entity behind almost all objects. Object.prototype. This is their father, object.prototype. And I wonder if we wrote object.prototype without defining anything, will you get anything? Nothing. Okay, let's clear first. Clear console. Say let what can I say? Empty p, and then object dot prototype. Object dot prototype. Okay, so I haven't gotten anything from that. Okay, just clear the console first. Let's stop embarrassing ourselves and just read. So console.log object.getPrototype of this argument is the same as object.prototype. Okay, fine. This is true. Let's look at this. What does this mean? This means that when you ask the console log, hey console log, object.getPrototype of this argument is the same as object.prototype. That's true, my friend. That's true. The console will tell us that's true. Console.log object.getPrototype of object.prototype. It's not a number. So as you can guess, object.getPrototype of returns the prototype of an object. The prototype relations of JavaScript objects form a tree-shaped structure, and at the root of this structure sits the object.prototype. You remember this when they said the ancestor? It sits at the root. It provides a few methods that show up in all objects. Okay, so prototype, object.prototype provides a few methods that show up in all objects, such as toString, which converts an object to a string representation. So that means an object prototype has these inbuilt methods that are inside it. So many objects don't directly have object.prototype as their prototype, but instead have another object that provides a different set of different properties. Functions derive from function.prototype, and arrays derive from array.prototype. So that means that objects, functions, and arrays have prototypes which exist in the JavaScript language. I think I'm right. We'll find out. So console.log object.getPrototype math.max is the same as function.prototype. That is indeed true. And also, So because this is a function math.mark. So when you say get prototype of this function, it's the same as function.prototype. And we say console.log object.get prototype of an array is the same as an array prototype. Ah, yeah, indeed that is true. Okay, so let's although yeah, let's not type that. So such a prototype object will itself have a prototype. Interesting. Often object.prototype, yeah, often it's object.prototype, so that it still directly provide methods like toString. So toString is a prototype that would exist in methods, objects. It's a toString is a method that would exist in objects, arrays, and function. You can use object.create, which is another method, to create an object with a specific prototype. Okay, so you can say let protoRabbit be speak line object, and then pass in the arguments this. See, this is the line. This the template the this dot type rabbit says line, and then we say let killer rabbit be object.create protoRabbit. Okay, so what have we just done? We have created a specific prototype called protoRabbit. This now exists as a prototype in our code. Killer rabbit.type will be killer. Killer rabbit.speak scree. The killer rabbit says scree. A property like speak line in an object expression is shorthand way of defining a method. It creates a property called speak and gives it a function as its value. The proto rabbit acts as a container for the properties that are shared by all rabbits. Okay, so this will create a prototype that is shared by all rabbits. So proto rabbit. An individual rabbit object like killer rabbit contains properties that apply only to itself. In this case, its type derives shared properties from its prototype. Classes. Okay, so that was thinking about objects. So now let's think about classes. Just made that font silent. So JavaScript prototype system can be interpreted as somewhat informal take on an object-oriented concept called classes. So this is a concept in object-oriented programming called classes. A class defines the shape of a type of object, what methods and properties it has. Such an object is called an instance of the class. Prototypes are useful for defining properties for which all instances of a class share the same value, such as methods, properties, and differ per instance, such as our rabbit's type property need to be stored directly in the object themselves. So, to create an instance of a given class, you have to make an object that derives from the proper prototype. But you also have to make sure it itself has the properties that instances of this class are supposed to have. This is what a constructor function does. So now we are being introduced to something called a constructor function. So here we have a function called makeRabbit by type, and we're going to pass in the following arguments. Let rabbit be object.create. We're going to create a new prototype called protoRabbit. So rabbit.type is type, return rabbit. Okay. So JavaScript provides a way to make defining this type of function easier. If you put the keyword new in front of a function call, the function call is treated as a constructor. This means that an object with the right prototype is automatically created, bound to this, which is a method, in the function. and returned at the end of their function. The prototype object used when constructing objects is found by taking the prototype property of the constructor function. Okay, so the prototype object used when constructing objects is found by taking the prototype property of the constructor function. So function rabbit type, this the type will be type, and then rabbit.prototype.speak, function line console.log, the this the type rabbit says line. Let weird rabbit be new rabbit weird. So this is a constructor property function. It will create a new prototype. Okay, so constructors, all functions in fact automatically get a property named prototype, which by default holds a plain empty objects that derives from object or prototype. You can overwrite it with a new object if you want, or you can add properties to the existing object as the example does. By convention, the names of the constructors are capitalized so that they can easily be distinguished from functions. It is important to understand the distinction between the way a prototype is associated with the constructor through its prototype property and the way objects have a prototype which can be found with object.getPrototype of. Okay, the actual prototype of a constructor is function.prototype since constructors are functions. Its prototype property holds the prototype used for instances created through it. Okay, so console.log object.getPrototype of rabbit is the same as function.prototype. So this has become a function. Console.log object.getPrototype of weird rabbit is the same as this rabbit prototype. This is also true. All right, I got the water. So let's read that again. Classes. JavaScript's prototype system can be interpreted as a somewhat informal take on an object-oriented concept called classes. A class defines the shape of a type of object, what methods and properties it has. Such an object is called an instance of the class. Prototypes are useful for defining properties for which all instances of a class share the same value. Okay, so for example, methods. Okay, so method is a prototype type. Properties that differ per instance, such as our rabbit's type property, need to be stored directly in the objects themselves. So this is different. This is interesting because now you can create a new instance of a prototype and it will be stored inside the object. So to create an instance of a given class, you have to make an object that derives from the proper prototype, but you also have to make sure it itself has the properties that instances of this class are supposed to have. This is what a constructor function does. Let's think about this. Okay, so where have we created a new instance? We need to have the one new. Okay, thank you. It's down here. Oh, okay, so this is the idea. So we had seen that we created a new prototype here. that is linked now to killer rabbit. So they're saying that this now becomes an instance of this prototype that has to be linked to this object proto rabbit, but how can I say it? I think I get it, but I just can't say it. But for you to have the same prototypes and methods, we need to create a new instance. Okay, and we do that using a constructor function. Okay, so function make rabbit type, let rabbit object dot create proto rabbit dot type return rabbit. When we run this, what do we get? It's undefined. Why is it undefined? JavaScript provides a way to make defining this type of function easier. If you put the keyword new in front of a function call, the function is treated as a constructor. It will construct a new instance. This means that an object with the right prototype is automatically created, bound to this in the function, and returned at the end of the function. The prototype object used when constructing objects is found by taking the prototype property of the constructor function. So function rabbit type, this dot type will be type. So and then rabbit or prototype speak will be function dot line. This is what it will say. And then we're going to create a new instance. Let weird rabbit be new rabbit. This is the function weird. Okay, given it weird. Constructors, all functions in fact automatically get property named prototype, which by default holds a plain empty object that derives from object.prototype. You can overwrite it with a new object if you want, or you can add properties to the existing object as the example does. Okay, you can just add to the existing object rabbit. Okay, by convention, the names of constructors are capitalized so that they easily be distinguished from other functions. But here new is not capitalized. So it is important to understand the distinction between the way a prototype is associated with a constructor through its prototype property and the way objects have a prototype, which can be found with objects.getPrototypeOf. The actual prototype of a constructor is function.prototype. Since constructors are functions, its prototype property holds a prototype used for instances created through it. So an instance, to create an instance, you're actually going to create a function. And to really prove this, we say that this object got get prototype of rabbit, this prototype thing. It's just the same as a function prototype, and it's true. Okay, and then also object will get prototype of weird rabbit is the same as the rabbit prototype. That is also true. So this is a function of prototype. So class notation. In JavaScript, classes are constructor functions with a prototype property. That is how they work. And until 2015, that is how you had to write them. These days, we have a less awkward notation. Okay, so now we have a less awkward notation, and I think before 2015, this is how you had to write them. But we have a less awkward notation now in year 6. So class rabbit, constructor type, pass this dot type speak line. Inside the line, pass console.log. The rabbit says this type and line. Then let killer rabbit be new. So it's a constructor function rabbit killer. Let black rabbit be new. Function rabbit going to input black. So the class keyword starts a class declaration. Okay, this class keyword starts a class declaration. Notice that up here we've just been using functions, but now we're starting with class. Okay. If I run this on my console, will anything happen? Or nothing, because I haven't actually asked it to run anything. Let me try to run console.log. Alright, it has given me black. And I think this is what I saw on YouTube. It's a new prototype that has been created. This is a good example now. And these are all the prototype that is in. So the constructor is class.rabbit, and then the speak function is this line, and then we have a prototype object. And these are prototypes that are in this. To string value of, let me find if I wonder if there's, but this is really cool because now this shows whatever the console now can really now make sense of what is happening. And I wish the author went to the console and showed us that all these things exist inside this now property new prototype black. Okay, so the class keyword starts a class declaration which allows us to define constructor and set of methods all in a single place. Any number of methods may be written inside the declaration's braces. The one named constructor is treated specially. So it provides the actual constructor function, which will be bound to the name rabbit. The others are packaged into that constructor's prototype. Okay, thus the earlier class declaration is equivalent to the constructor definition from the previous section. It just looks nicer. So this is similar to this, and I think we can say it just looks nicer because now we defining this class called rabbit. Okay, class declarations currently allow only methods, properties that hold functions, to be added to the prototype. This can be somewhat inconvenient when you want to save an unfunction value in there. The next version of the language will probably improve this. For now, you can create such properties by directly manipulating the prototype after you've defined the class. Like function, class can be used both in statements and in expressions. When used as an expression, it doesn't define a binding, but just produces the constructor as a value. You are allowed to omit the class name in a class expression. So let object new class be this. Get word function, return hello, console.log object.getWord hello. Okay, this is all part like the JavaScript syntax, and I think as the more we continue, the more we're seeing this syntax and we're understanding where it exists and why it exists alongside the normal ones. Overriding derived properties. When you add a property to an object, whether it is present in the prototype or not, the property is added to the object itself. If there's already a property with the same name in the prototype, this property will no longer affect the object, as it is now hidden behind the object's own property. So when you add a property to an object, whether it is present in the prototype or not, the property is added to the object itself. If there was already a property with the same name in the prototype, okay, so this again, overriding derived properties. When you add a property to an object, whether it is present in the prototype or not, the property is added to the object itself. If there's already a property with the same name in the prototype, this property will no longer affect the object, as it is now hidden behind the object's own property. Let's look at it here. Rabbit.prototype.teeth is small. Console log killer rabbit.teeth. It will tell you small. Let's just confirm that. Don't want to type it. Alright, so rabbit prototype teeth is small. Console.log killer rabbit.teeth will tell you small. How come and it undefined? We haven't defined killer rabbit in our console, but I think it understands. That's why it tells me undefined though, I think so. But that's also why it passes this small, because it is a part of this prototype. Okay. Killer rabbit teeth, long, sharp, and bloody. Console log killer rabbit teeth, and then it will give you this long, sharp, and bloody. Console.log black rabbit.teeth is small. Console.log rabbit.prototype.teeth, it will tell you small. The following diagram sketches the situation after this code has run. The rabbit and object prototypes lie behind the killer rabbit as a kind of backdrop, where properties that are not found in the object itself can be looked up. So this killer rabbit has a bunch of object prototypes like teeth and type, and this rabbit prototype has okay, let's read that again. The following diagram sketches the situation after the code has run. The rabbit and object prototypes lie behind killer rabbit as a kind of backdrop, where properties that are not found in the object itself can be looked. Okay, so this is killer rabbit. I think this is at the front, and then under it we have teeth.small, but the rabbit prototype lies under here, and then the object properties lies under here. Overriding properties that exist in a prototype can be a useful thing to do. As the rabbit teeth example shows, overriding can be used to express exceptional properties in instances of more generic class of objects, while letting the non-exceptional objects take a standard value from their prototype. Overriding is also used to give the standard function and array prototypes a different toString method than the basic object prototype. For example, an array prototype.toString is equals to object prototype.toString false, that is not true. Console.log array12.toString call, it will give you 1, 2. Calling toString on an array gives a result similar to calling .join a string on it. it puts commas between the values in the array. Directly calling object.prototype to string with an array produces different string. That function doesn't know about array, so it simply puts the word object and the name of the type between square brackets. So for example, because it doesn't know, when now you say console.log and reverse this, object.prototype.toString call array1 and 2, to just give you an array or called object array. Cool. Maps. So we saw the word map used in the previous chapter for an operation that transforms a data structure by applying a function to its elements. Confusing as it is, in programming, the same word is also used for related but rather different thing. A map, noun, is a data structure that associates values. This is the keys with other values. For example, you might want to map names to ages. It is possible to use an object to this. So let ages be object Boris 39, Liang 22, Julia 62. Console.log template literal Julia is placeholder ages and then array Julia. It will tell you Julia is 62. Notice how when you call ages array in this what can I say, in this object, it gives you the age. So let's just try it just so that we can prove it. It's true. Control C, clear console, Control V. Julia is 62. Quite interesting. This also shows us how arrays, that you can call an array using a method, and it will give you that. Console.log is Jack's age known, comma, Jack in ages. So it will tell you false. Console.log is to strings age known, to string in ages is to strings age known true. Here, the object's property names are the name, people names, and the property values and their ages. But we certainly didn't list anybody named to string in our map. Yet, because plain objects derived from object.prototype, it looks like the property is there. To string actually exists in a prototype. So it's true. As such, using plain objects as maps is dangerous. Okay? There are several possible ways to avoid this problem. First, it is possible to create objects with no prototype. If you pass null to object.create, the resulting object will not derive from object.prototype and can safely be used as a map. Okay, so if I want to use an object as a map, I can use null, and because it will not call the object.prototype. Okay. Object property names must be strings. If you need a map whose keys can easily be converted to strings such as objects, you cannot use the object as your map. Fortunately, JavaScript comes with a class called map. Okay, so this is different from maps. This is another class called map that is written for this exact purpose. It stores mapping and allows any type of keys. So let ages be new map function, ages set Boris 39, Liang 22, ages set Julia 62. Console.log Julia is ages.get Julia, it will tell Julia 62. And now we're repeating this code, but now we are using this class called map. The method set this one, set this one, get, and has are part of the interface of the map object. Ooh, okay, so map object has three interfaces: the set, get, and has. Writing a data structure that can quickly update and search a large set of values isn't easy, but we don't have to worry about that. Someone else did it for us, and we can go through the simple interface to use their work. If you do have a plain object that you need to treat as a map for some reason, it is useful to know that object.keys, this one, returns only the object's own keys, not those in the prototype. As an alternative to the in operator, you can use the has own property method, which ignores object's prototype. So console.log object x is 1. It has own property x, true. Console.log, it has own property called to string, false. Polymorphism. Okay. So when you call a string function, which converts a value to a string on an object, it will call the toString method on that object and try to create a meaningful string from it. I mentioned that some of the standard prototypes define their own version toString so they can create a string that contains more useful information than object array. You can also do that yourself. You can say rabbit.prototype.toString is equals to function. Inside the function, return a this type rabbit. So inside the function, return a type rabbit. Console.log to string black rabbit, a black rabbit. This is a simple instance of a powerful idea. Okay. When a piece of code is written to work with objects that have certain interfaces, in the case a to string method, any kind of object that happens to support this interface can be plugged into the code and it will just work. This technique is called polymorphism. Polymorphic code can work with values of different shape as long as they support the interface it expects. I mentioned in chapter 4 that a for or off loop can loop over several kinds of data structures. This is another case of polymorphism. Such loops expect the data structure to expose a specific interface, which arrays and strings do. And we can also add this interface to our own objects. But before we do that, we need to know what symbols are. It is possible for multiple interfaces to use the same property name for different things. For example, I could define an interface which the toString method is supposed to convert the object into a piece of yarn. I think that's a string. It would not be possible for an object to conform to both that interface and the standard of toString. That will be a bad idea. And this problem isn't that common. Most JavaScript programmers surely don't think about it. But the language designers whose job is to think about this stuff have provided us with a solution anyway. When I claimed that property names are strings, that wasn't entirely accurate. They usually are, but they can also be used as symbols. Symbols are values created with the symbol function. And like strings, newly created symbols are unique. You cannot create the same symbol twice. So let sim be symbol name. Console.log sim is the same as symbol name, false. Okay. Rabbit.prototype sim is 55. console.log rabbit black rabbit sim is 55. The string you pass to symbol is included when you convert it to a string and can make it easier to recognize a symbol when, for example, showing it to the console, but it has no meaning beyond that. Multiple symbols have the same name. So being both unique and usable as a property, names make symbols suitable for defining interfaces that can peacefully live alongside other properties, no matter what their names are. Okay, that's now when it makes sense to actually use a symbol. Const to string symbol is to string, array prototype to string symbol, then you call function, return this length centimeter of boolean. Console.log 1 2 to string, it will give you 1 2. Console.log 1 2 to string symbol, it will tell you 2 centimeters of blue yarn. It is possible to include symbol properties and in object expressions and classes by using square brackets around the property name. That causes the property name to be evaluated, much like the square brackets property access notation, which allows us to refer to a binding that holds the symbol. So let string object be object to string array, call it return a geotrop. Console.log to string object call a geotrop. Okay. Okay, so now we move to the iterator interface. The object given a for of loop is expected to be iterable. You can iterate on it. This means it has a method named with the symbol with the symbol.iterator symbol. A symbol value defined by language stored as a property of the symbol function. When called, the method should return an object the method should return an object that provides the second interface iterator. This is the actual thing that iterates with symbol.iterator. It has a next method that returns the next result. That result could be an object with a value property that provides the next value. If there's one and a done property, which would be true when there are no more results, or false otherwise. So this iterator symbol will create a for loop. Note the next value and done property names are plain strings, not symbols. Only symbol.iterator, which is likely to be added to a lot of different objects, is an actual symbol. Okay, we can directly use this interface ourselves now. So let's look at it. Let OK iterator be OK symbol.iterator call console.log OK iterator.next call. It will give you an object value 0 done false. Console.log OK iterator next, it will give you value k done false. Console.log OK iterator next, it will give you value undefined done true. Okay, so let's implement an iterable data structure. We'll build a metric class acting as a two-dimensional array. So class matrix, we're going to have an object and we have a constructor with height element is xy, the arrow function is undefined, and then this dot width is width this dot height is height, this dot content is an empty array. Okay, let's create a for loop. For let y be 0 and y is less than height, iterate y plus 1. For, that's the next for loop. For let x is 0 but x is less than width, iterate x plus 1. This dot content into the array times width plus x is equals to element xy. Step out, step out, step out of that. Get x dot y. This return dot content y times this dot width plus x. Okay, set x y value. Then inside this, call this dot content y this dot width plus x is equals to value, and then step out of that data structure. Okay, so it's going to be undefined because we haven't actually defined our thing. That's actually really interesting that we're using everything we've learned before. So let's think through what we've just done. The class stores its content in a single array of width times height elements. Okay, this class. The elements are stored row by row. So for example, the third element is the fifth row, is using zero-based indexing, stored at position 4 times width plus 2. Alright, so let's try that again. The iterator interface. So the object given to a for of loop is expected to be iterable. This means it has a method named with the symbol dot iterator symbol, a symbol value defined by the language stored as a property of the symbol function. When called, that method should return an object that provides a second interface, iterator. This is the actual thing that iterates. It has a next method that returns the next result. The result should be an object with a value property that provides the next value if there is one, and a done property which should be true when there are no more results, and false otherwise, so it iterates. Okay, so we just look at this funny code. So the class stores its content in a single array, okay, of width times height elements. The elements are stored row by row. So for example, the third element in the fifth row is using zero-based indexing, stored at what position? 4 times width plus 2. The constructor function takes a width, a height, and an optional element function that will be used to fill the initial values. There are get, set, and set methods to retrieve and update the elements in the matrix. When looping over a matrix, you're usually interested in the position of the elements as well as the elements themselves. So we'll have our iterator produce objects with x and y and value properties. So here we have a class matrix iterator object. We have a constructor matrix. This dot x is 0, this dot y is 0, this dot matrix is matrix. So this is like an array, but it's an object. Close, step out of that. Call this next. If this dot y is the same as this dot matrix height, return done true. This is another object. Left value object x, this dot y, this dot x, y, this dot y. Value this dot matrix dot get this dot x dot this dot y. This is the value. This dot x plus plus, this is the iteration now. If this dot x is the same as this dot matrix dot width, we're going to run this argument. This dot x is 0, this dot y iteration plus plus. Return value done false. This God just made me so scared. But we're going to go back and go over it. So the class tracks the progress of iterating over a matrix in its x and y properties. The next, this one, method starts by checking whether the bottom of the matrix has been reached. If it hasn't, it first creates the object holding the current value and then updates its position, moving up to the next row if necessary. Let's set up the matrix class to be iterable. Throughout this book, I'll occasionally use after the fact prototype manipulation to add methods to classes so that the individual pieces of code remain small and self-contained. In a regular program, where there is no need to split the code into small pieces, you declare these methods directly in the class instead. Okay, like this. So we can now loop over a matrix with for or off. And here we are seeing how you can loop over a matrix with this method, symbol iterator. Okay. Getters, setters, and statics. Interfaces often consist mostly of methods, but it's okay to include properties that hold non-function values. For example, map objects have a size property that tells you how many keys are stored in them. Okay. It is not even necessary for such an object to compute and store such a property directly in the instance. Even properties that are accessed directly may hide a method call. Such methods are called getters. They are defined by writing get in front of the method name and an object expression or a class declaration. Let varying size be object, get size, return math random times 100. Console.log varying.size 73. Console.log varying.size 49. Whenever someone reads this object size property, the associated method is called. You can do similar thing when a property is written to using a setter. Alright, so class temperature, constructor Celsius, this dot Celsius Celsius, get Fahrenheit. Okay, so this is a getter. Return this dot Celsius. We have this math. Set Fahrenheit value to this dot Celsius equals to value minus 32 over 1.8 divided by 1.8. Okay, static. So this is the static one. So we have a setter and a static. From Fahrenheit value, return new temperature, this. Let temperature, new temperature. So we learned this is also it's a class notation. Alright. Let temperature, new temperature be 22. Console.log temperature.Fahrenheit is 71.6. Temp.Fahrenheit is 86. Console.log temp.Celsius will give you 30. So the temperature class allows you to read and write the temperature in either degree Celsius or degrees Fahrenheit. But initially, it stores only Celsius and automatically converts it to Celsius to Fahrenheit in the getter and setter. Sometimes you want to attach some property directly to your constructor function rather than to the prototype. Such methods won't have access to a class instance, but can, for example, be used to provide additional ways to create instances. Inside a class declaration, methods have static, written before their name, are stored on the constructor. So the temperature class allows you to write temperature dot from Fahrenheit 100 to create a temperature using degrees Fahrenheit. And then we're going to talk about inheritance. And all this is just about, I think, um, or the methods in objects. I think that's what the secret life of objects is all about. The methods that are in objects, so inheritance. Some matrices are known to be symmetric. If you mirror a symmetric matrix around its top to left to bottom right diagonal, it stays the same. In other words, the value stored at xy is always the same as that at yx. Imagine we need a data structure like a matrix, but one that enforces the fact that the matrix is and remains symmetrical. We could write it from scratch, but that would involve repeating some code very similar to what we already wrote. JavaScript's prototype system makes it possible to create a new class, much like the old class, but with new definitions for some of its properties. The prototype for the new class derives from the old prototype but adds new definition for, say, the set method. In object-oriented programming terms, this is called inheritance. The new class inherits properties and behavior from the old class. Class, so here we're going to look at this code. So this is a class, symmetric matrix, extends matrix, constructor, and then we also have another constructor here. Size element is going to be xy, arrow function, and defined. So function undefined xy. Super, I don't know what this means. Size, arrow function xy. If x is less than y, return element yx. Else return element xy. Step out of it. Set x, y value. Superset x, y and value. If x is not y, superset y, x value. Then step out of it. Let matrix be new symmetric matrix 5xy template literal xy console.log matrix.get 2 3. You're going to get 3 2. Let's look at that. I can't wait to really break this down. 3 2. Interesting. The use of the word extends indicates that the class shouldn't be directly based on the default object prototype, but on some other class. This is called superclass. The derived class is the subclass. To initialize a symmetric matrix instance, the constructor calls its superclass constructor through the super, this one that I've just said I don't know about it, keyword. This is necessary because if this new object is to behave roughly like a matrix, it is going to need the instance properties that matrices have. To ensure that a matrix is symmetrical, the constructor wraps the element function to swap the coordinates for values below their diagonal. The set method again uses super, but this time not to call the constructor, but to call a specific method from the superclass's set of methods. We are redefining set, but do want to use the original behavior. Because this .set refers to new set method, calling that wouldn't work. Inside class methods, super provides a way to call methods as they were defined in the superclass. Inheritance allows us to build slightly different data types from the existing types with relatively little work. It is a fundamental part of the object-oriented tradition, alongside encapsulation and polymorphism. But while the latter two are now generally regarded as wonderful ideas, inheritance is more controversial. Whereas encapsulation and polymorphism can be used to separate pieces of code from each other, reducing the tangledness of the overall program, inheritance fundamentally ties classes together, creating more tangle. When inheriting from a class, you usually have to know more about how it works than when simply using it. Inheritance can be a useful tool, and I use it now and then in my own programs, but it shouldn't be the first tool you reach for, and you probably shouldn't actively go looking for opportunities to construct a class hierarchies, family trees of classes. The instance of operator. It is occasionally useful to know whether an object was derived from a specific class. For this, JavaScript provides a binary operator called instance of. Console.log new symmetric matrix times 2 instance of symmetric matrix is true. Console.log new symmetric matrix times 2 instance of matrix is also true. But new matrix 2 into instance of symmetric matrix is false. And console.log array of 1 is an instance of an array that's true. The operator will see through the inherited types. So a symmetric matrix is an instance of matrix. The operator can also be applied to standard constructors like array. Almost every object in an instance of object. Summary. So objects do more than just hold their own properties. They have prototypes, which are other objects. They'll act as if they have properties they don't have as long as their prototype has that property. Simple objects have object.prototype as their prototype. Constructors, which are functions whose names usually start with a capital letter, can be used with a new operator to create new objects. The new object's prototype will be the object found in the prototype property of the constructor. You can make good use of this by putting the properties that all values of a given type share into their prototype. There's a class notation that provides a clear way to define a constructor and its prototype. You can define getters and setters to secretly call methods every time an object's property is accessed. Static methods are methods stored in a class's constructor rather than its prototype. The instance of operator given an object in the constructor tell you whether that object is an instance of that constructor. One useful thing to do with objects is to specify an interface for them and tell everybody that they're supposed to talk to your object only through that interface. The rest of the details that make up your object are now encapsulated, hidden behind the interface. More than one type may implement the same interface. Code written to use an interface automatically knows how to work within any number of different objects that provide that interface. This is called polymorphism. When implementing multiple classes that differ in only some details, it can be helpful to write the new classes as subclasses of an existing class, inheriting part of its behavior. And then now we're going to have a bunch of exercises, which I'll come back and look at it. And so that was us reading through Secret Life of Objects, which is basically talking about the methods that are encapsulated within. Stop.